Hello everyone. So today I want to present you how you can work with the SwiftUI data flow with Redux. So first, what is Redux? Well, Redux is a design pattern. It's a design pattern to architecture your application data flow. The goal of Redux is to centralize all your application states and business logic into one place, into one state. And if I'm doing the talk today, it's because, well, I love it. So I guess you're not very familiar with Redux, so I'm going to go again over it. So the goal of it is to have a single source of truth, a single state that contains all your data, application data that need to present in views. So all your business logic in one place. And it's a unidirectional data flow. It means like you will not mutate your data, have class around, have instance of classes, have structure around. You will have one state, and your view will dispatch what we call action that will generate a new state in reducers. And those views subscribed to this state will get this new state and display the new data. And the data will flow only in one way. So with this architecture, it's very easy to build isolated and reusable UI component because they are free of any business logic. So let's take a look at the diagram, Redux data flow. So in the green part, the components will be your actual SwiftUI view in our context. Your view will dispatch action. Your action is a simple structure that contains whatever necessary for the reducer to generate a new state. So the reducer takes an old state, your action, and will generate a new state that will be assigned to your store, and all your SwiftUI views subscribe to this state. Will refresh the content. And in the case of SwiftUI will do the actual diffing of the old and new state and refresh only what's necessary in your view. This is very important because if you was doing that in UIKit, it will be much more complex. And in the case of SwiftUI, you can implement it very easily. So let's dig into SwiftUI. So if I want to implement the store class, I will do an observable object. It means that SwiftUI will be able to subscribe to this object, and I will wrap my state properties into a property wrapper called published. It means that all the subscribers of all the SwiftUI views subscribed to this class will get notified when the state will change. And then if you look at this code, it's usually done in the same delegate. If you make a new SwiftUI application from Xcode, a new project, you will first instantiate your store, your state. Then you will make your hosting controller, and you will instantiate your initial view. Here I'm calling it home view. Then I will inject my store into what's called view modifier environment object. It means that in any subviews of this view hierarchy, so in any view in my app, actually, I can use the environment object property wrapper to access my store instance. So from there, I can use my store directly to calculate, to compute properties on my view, or I can use it directly in the body. And anytime those value of my in my state will change, my view will get updated. So this is good, but it is not really like what looks like the modern Redux syntax in a React application, for example, if some of you are familiar with web development. So I've made an open source library called SwiftUIRedux, and the goal of it is to make it cleaner. So you will not access the store variable directly, and you will be forced to derive your view properties from your store into local view properties. And so the goal is to make it cleaner and closer to a modern React and Redux syntax. So around that, I made an application. It's a fully open source SwiftUI application. Only SwiftUI, no UIKit. I've tried to make it as far as I could with SwiftUI. So you can take a look. It's a great starting point if you want to make SwiftUI application. There is like custom animation. There is like a lot of SwiftUI components. There is the Redux data flow, a lot of different SwiftUI data flows. So you can look at it and dig into it to get started. So now let's look at it. At what it looks like now that I use my library SwiftUIRedux. So instead of directly injecting the store, I will wrap my home view into a container view called store provider. Store provider is just some shortcut to actually do the same. It takes my content view and it injects my store as environment object. But later, when I will add more feature, you'll be able to benefit from it if you use a store provider. One of the most important components, actually the most important component, is connected view. So instead of conforming to the view protocol when you make a new SwiftUI view, you will now conform to the connected view protocol. And connected view protocol will offer you a life cycle. So when you will dispatch an action, it will generate a new state. Your view will receive this new state, and it will call two functions. The first function is map state to props. So here you can extract your property from your state and compute them to local view properties. And then it will call a new function, a body function, with your props. So here you can use your props to display your actual data. And to illustrate this lifecycle, I want to take a very simple example. I want to take a context menu. So I'm not talking about the cell under the context menu, but the context menu itself, the add to fun club and remove from fun club with a little image. So I'm creating my people context menu with which conform to connected view. So I have to provide props. And the only thing I want to know is this people, this actor, is in my fan club or not. So I just need one Boolean, and here I'm wrapping the Boolean into what's called a binding, and it's a custom binding. So it's very powerful because it means I will be able to write a getter and a setter. And then SwiftUI will call my map state, my framework will call my map state to props function. And here I'm creating my custom binding. So in the getter, I'm just deriving asking my state if the fan club contains this actor. And in the setter, this is where it gets interesting, I'm dispatching action. It means that when you will toggle this Boolean from the UI, it will actually emit action that will modify the state. So your view will stay up to date. If you look at the body, it's very simple now. When you click the button, it toggles my Boolean, and when you on the text is only a text and an image, and it uses this property. So let's take a look at how it all works in the background. So I have my store, as we saw before. We created with the initial application state. My application state is a movie state and a people state. So you have two states. My people state is a normalized dictionary of people. So ID of people are int, two people, object. And my fan club is a set of those people ID. My action is just like to action, add to fan club and remove fan club. So it takes people, just the ID of these people. And the dispatch function. The goal of the dispatch function in my SwiftUI Flux library is to take the current state and take the action, and the reducer will return the new, will evaluate the action and return a new state. So if you look at my reducer, my main application reducer, I reduce my movie state and my people state. And the most interesting part, where I want to go, is my people state reducer. Here I'm catching my action, and I'm actually creating a copy of my state and modifying my state and returning the new state. So if you want to, it inserts the people in the fan club or remove from the fan club if you do this action. And so that's how it works on how my whole state, my whole application is aware of the current state of the application and how my view gets updated. I wanted to show you one more example. In this case, if you look at the wishlist button, if you look at it gets animated. So this wishlist button is bind to my state to know if you look at props is in wishlist or not. And what I want to show you is that SwiftUI will honor your animation. Even if I mutate a whole part of my state in my reducer, SwiftUI will still make the diff and only update what's necessary. So if you have some animation on button, it will not refresh the whole view or everything. It will refresh only the wishlist button and still make your animation. Here is one more example. In this case, I want to show you what's the little component that control when you add the movie to a wishlist, for example, a within list, it controls the image that gets displayed on the row. So this component just needs to know three things, like if it's in wishlist, thin list, or custom list. Then call my mapSet to prop function. Same, I derive my three Boolean from my store. And my view body is very simple. I'm just displaying my image with the current image, depending on my props, and with an animation, and that's it. That's it. So when I add a movie to my wishlist, my whole application gets updated. My wishlist is updated in different tabs of my application, but also this little component will get animated because now the movie is in my wishlist. So to conclude, Redux is allow you to really easily separate your business logic from your UI logic, so easy separation of concern. It works great with SwiftUI built-in data flows, wrappers, and helpers. So it works great with published, observable object, observable object. You don't need to create new things. You can work with what SwiftUI and Combine provide. And so view components are very small, clean, reusable, and ampy of any business logic. You don't do computation in it. You don't do any state modification, mutation. You just display the current state on dispatch action eventually. So you can focus on your UI code, and all your business and models bugs will be actually in your reducer, while your business matter is in your state, in your object graph, and in your reducer. So I hope you enjoyed this talk, and you will enjoy the rest of the conference. And thank you.
Thank you. Thank you. Thank you, Natalia. So Thomas, Natalia, please join us
Well, so putting testing and fun in the same talk, it was a challenge, but you nailed it.
I love it.
Yeah.
It's fun,
I
really.
trust, yeah. This new approach of UI code is changing the way you need to test, because some of us with like nib files or storyboards got used to probably not test exactly all the UI code. I'm seeing some people getting high. So what do you think this new approach will change in terms of UI testing? Do you need to test more and to have a larger coverage, especially in UI code?
I think it should not change the way you approach testing in your product, like in your company. You need to be, I think, very mindful about what standard you are going for. There are definitely applications that don't need a lot of automation. Small applications that is more manageable to do it like on your own or like manual tests. But yeah, I think we should keep the same standards, basically.
And can you tell us a bit more about what it changes about XC UI tests? Can you still use that?
Yeah, it doesn't change, I think, almost anything about XUI test, except that there are some, like people are struggling to find the elements using the XPaths, but that's just, I think, the frameworks. But apart from that, XUI tests are for integration tests, which are black box tests, so it doesn't really matter how you implement your UI. And that's why I focus more on the white box testing, where you can actually go to specific states easier.
Nice. When you come to like the same question as before, like when you come to moving to SwiftUI and gradually integrating SwiftUI into a real-world application, I think you've done that. Do you have some advices to gradually adopt and learn and ship that code?
Well, yes. At Glows, like the application I'm working like full time, you can actually, if you want to ship some feature only on iOS 13, you can with SwiftUI, and it's actually recommended. Like, I would recommend to ship some SwiftUI feature to try. You can really easily like transition from UIKit view to a new like SwiftUI view and build something you want in SwiftUI in it. And yeah, you will only be able to ship this feature on iOS 13, but why not? I think it's time to do it right now.
Yeah, it's a good way to actually learn.
Yeah, to try SwiftUI on, yeah.
Yes. So we spoke about architecture finally because we've seen like MVC by Apple since the 80s, basically. We're seeing something different. If I'm not mistaken, there are some slides from Apple's talk mentioning view models.
Yeah.
That's amazing. Is that actually finally changed once for all, in your opinion?
Apple had a really great conference about the SwiftUI data flow, and they didn't mention Redux or anything like that, but they strongly hint at it, that you should, like, it's built with a state with operative wrapper like published, observable object, and state. It's built for like some kind of unidirectional data flow, and yeah, it's moving like, you can have a view model, you can have a model on a view, and actually even like maybe bypass the view model, and yeah, that's moving. We're moving to a new direction.
I think again, like with the delegates that were shown before, like some parts of Apple might be like using this, and some others might ship still APIs with that don't allow us to do this. But anyway, I think Apple videos and docs will always cover the more general case, and it's up to us to like define how we want to deal with separation of concerns. I think Redux is a great implementation of that, and it might be a little bit too much for some people, so they can start with smaller steps to achieve unidirectional data flow.
Yeah, and actually that's what I was saying. Like SwiftUI offer you like great tools to actually do that very easily with primitive wrappers. So Redux it's really good if you're making like some bigger application, but you can totally. Yeah.
And can you tell us more about Redux and its history and where you?
Yes. So Redux got quite popular because of React. React on Redux is React is on Facebook. It's a front-end web application JavaScript framework, so you can make web app with it. And I strongly hint that you should use Redux with it. Actually, you have to use Redux with it. And it's got popular from there. It doesn't come from Facebook. It's like it's older. It was used in game and it's a state machine. So, but it got quite popular with React, and there is actually a lot of open source implementation of it in various languages. For UIKit, for Android, for a lot of languages, there is actually Redux library today.
Yeah, it's more an approach than.
Yeah, it's more an approach than it's just a design pattern for your data.
And I remember when Facebook launched React Native back in 2015, 16, forgot. They said that React was like a kind of a learn once, run everywhere thing. Is that, I mean, are we like getting closer to that? I mean, can we finally like have a meeting with our web developer friends and say, okay, this is gonna be the implementation, more or less, of course not into detail, and then all front-end apps can just have this implementation?
Alors, because of Redux, actually, at Close, we're working all our clients, like iOS, Android, on the web, use Redux, so we have really common languages to talk about these technologies. When we create a new feature, we have the same language, like how we architecture this feature. And in terms of front-end code, because of SwiftUI, it's actually really close. When you look at the code for SwiftUI component and the code for React components, on top of that, if you use Redux in your SwiftUI app, it's actually really, really close in terms of syntax. You could almost think like Swift look like JavaScript.
Okay. Yes.
And Natalia, did you look at that kind of frameworks to get to imagine your new ideas of how to test that?
Oh, well, I looked into how web is doing things. I also tried to look into how Android is doing because they have the compose thing. Yeah, that was introduced this year. So looks like we are catching up and everyone is moving in the same direction. At least that's good. Yeah, and in terms of React, the testing strategies that I saw are mostly around either snapshot testing. Well, it's not either or, actually, people combine them, like snapshot testing, but also there is this testing where you can query, similar to expats, you say, I want a button, and there you're actually testing that the thing change. You're not testing that when you call a method, it will change some internal state.
Sorry, can you quickly explain what snapshot testing is? Because I'm not sure everyone is familiar with.
So it was in the talk. You were not very focused,
no,
but.
Okay, catch.
But I think it's completely understandable because you're doing great work with the conference and it's going very smooth. So, yeah. But snapshot testing, you capture one version of a view, or it can be of any other object, actually, and then you compare it with another version of the same object, and if they match, the test passes, and otherwise it fails.
Yeah. Okay. Thank you.
So,
sorry for that strange question.
For information, Mathieu has 3 children. He's running like 3 companies, building a conference at the same time.
It's hard also backstage to
should we
follow
give them
everything.
a round of applause?
Oh, thank you.
We talked about the business logic in views. One thing, I fear when I see like Apple examples sometimes in SwiftUI is that there is there is a lot of at-state properties. Is that safe to use, or is just like safe-ish for and demo purposes or simple projects?
If you make like a small app with few components, it's very, very safe to use. The problem starts when you get one root component and you have like a lot of state that you pass with the binding, by binding to few other components. So you have to pass them in the initializer of your new view. And sometimes you have like, you start to have like a hierarchy of view and you pass them, you have that state somewhere and binding somewhere else. It can get complicated, and that's why you can use Redux.
Mm-hmm. Okay.
Actually, in that session that I showed from Apple about master Xcode previews, they have an example where they have a state, and then they want to see two different versions of that view in the previews, and they can't directly because you are not able to access state from outside of the body function. That's literally the error message that you get. So what they do is they actually create a container, and they put the content inside a container and create a binding. So yeah, that's one thing about states, that it's always a little bit more than just having a state. And I think it's completely different talk, and very long talk probably, about all of these property wrappers for dynamic behavior that we get, like read and write access. I have a lot of
We'll have a
opinions
talk
about that.
on property wrappers later tomorrow. And if you want to join the CFP for next year with the advanced talk on that, you're more than welcome.
Sure.
Last question. Okay.
I think we will move on to the next speaker.
It was
I'm sorry.
Yes, please.
Okay, thank you very much for your talks.
Thank you.